Hey guys, this is Miss Heffman from Glenwood Elementary School. I hope you're having a fabulous Tuesday. It's a little cloudy outside today, but it's still good weather to go out and play. We're going to do another math problem today that is a different type of word problem. So let's look at our standard, and we have two standards today. Hello, Sebastian. So I'm going to move this right here. Maybe. Sorry, making you a little sick. Oh, there it is. All right. We have 1.NBT.3 compare two-digit numbers greater than, less than, or equal to. And then we have 1.OA.2 solve word problems that add three single-digit numbers to get a sum less than 20. So I'm going to take back here. I'm going to sit this down. We're going to do our warm-up. Are you ready to warm up? Here we go. We're going to count because in first grade, we count to 150 and we're supposed to start at any number. So today, we're going to start at the number 80. Are you ready? 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123, 124, 125, 126, 127, 128, 129, 130, 131, 132, 133, 134, 135, 136, 137, 138, 139, 140, 141, 142, 143, 144, 145, 146, 147, 148, 149, 150. You did it! And I hope each of you are practicing counting to 150. So I'm going to adjust my tripod one more time so that you can see our math. And I'm actually going to go up a little bit with this. So let's see, scoochy, scoochy back. Okay, so before we start, do you remember that I said in a number, there's digits in numerals? And numerals are just symbols that represent our numbers. So here we have the number 14. The 1 is a digit in 14, and it's in the tens place. And the 4 is a digit in 14, and it's in the ones place. So we have the tens place and the ones place. Now all of these objects you see all have the same value. They all have the same value of 14. Hey, Rayleigh. So even though they all look different, they all have the same value of 14. So keep that in mind as we work on our math problem today. So let's read our problem. It says, scoochy, scoochy, make sure I can see it. Matt has 5 red Skittles, 3 green Skittles, and 5 yellow Skittles. Meg has 3 purple Skittles, 5 green Skittles, and 5 yellow Skittles. Do they have the same number of Skittles? I wonder. How do you know? So, just like when you read a book, sometimes there's 2 characters. So this math problem is not any different. There's 2 characters. Who was our first character? Does anybody remember the first character? Did you say Matthew? Good job. Okay, who was the second character that we were talking about in this math problem? Jill, that's right. And they both had some Skittles. I love Skittles, so I have some Skittles right here. But first, let's read this problem one more time. Are you ready? Matt has 5 red Skittles, 3 green Skittles, and 5 yellow Skittles. So I'm going to put Matt's out first. So I have some Skittles. Oops, my hand got caught. So he first had 5 red. So I'm going to put out his 5 red. So there's his 5 red. I'm going to put them in a nice row. Then he had 3 green. So I'm going to take 3 green and put right here. And then Matt had 5 yellow. So I got to take 5 of the yellow and slide them up here. So there is Matt's Skittles. Now I've got to do Meg's Skittles. Meg had 3 purple Skittles. She had 5 green Skittles. And she had 5 yellow Skittles. Do you notice what I notice? Those look quite similar. So I'm going to use the parts equal total structure to help me to solve this problem. So I'm going to draw a big long rectangle, and I need to know how many there are. Well, I don't know, but I know that down here he had 5 red. 1, 2, 3, 4. 1, 2, 3, 4, 5. So I'm going to color those red. And yes, I know I drew one too many, but it's okay. I'm going to need that one. 1, 2, 3, 4, 5 red. He had 3 green. So I can color those. 1, 2, 3. And the colors really make it visual. And then he had 5 yellow. 1, 2, 3, 4. Oopsie, this should meet. So we'll delete that right there. 1, 2, 3, 4, 5. So we don't need that right there. Pretend like that's not there. You don't see that, okay? You don't see that. So then he had 5 yellow. 1, 2, 3, 4, 5. So I'm going to mark that. 5 red, 3 green, and 5 yellow. Now, the total, or the whole, I don't know. But I can figure it out. Can you help me figure it out? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our mystery number, our mystery total is 13. And I can also write that in an equation. Sorry, my dogs are going nuts. Probably barking at a rabbit. Excuse me, one second. Sorry guys, real life here. So the way I would write this math equation, now I know that 5 and 5 makes 10. So I'm going to write 5 plus 5 plus 3 equals my mystery. So I know that 5 and 5 makes 10. And then 10 and 3 more makes 13. Good job. Now we're going to solve Meg's and see if we come up with 13. Okay? Hold on, I gotta take care of the dog. Sorry guys, sorry. All right, so let's do Meg's. So I'm going to draw here Meg's total at the top because I want to know her total as well. So this time, so I don't mess up. So she had 3 purple. So I'm going to get my purple. And there's her 3 purple. And then she had 5 green. 1, 2, 3, 4. 5 green. And then she had 5 yellow. 1, 2, 3, 4, 5. And where's my yellow? Right there. Now, I can count my Skittles to find my total, or I can count this. And I need to label this too. So 3 purple, 3 green, and 3 yellow. So I'm going to, oops, that's supposed to be a 5, not a 3. Sorry. There we go. So 3 purple, 5 green, and 5 yellow. My dogs has got me all discombobulated because they keep barking. There we go. So sorry. They won't stop barking. And they're barking at nothing. So let's count. I'm going to grab the 3 this time and count on. Are you ready? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13. We have the same total of 13. So I'm going to go right over here and I'm going to do the equation that matches Meg's problem. So again, I'm going to write, I know that 5 and 5 makes 10. So I'm going to say 5 plus 5 and 3. So 5 plus 5 gives me my 10 plus 3 more equals 13. So I can write Matt has 13 Skittles. Meg has 13 Skittles. So now I've solved my problem. Do they have the same number of Skittles? Well, 13 and 13 are what? Did you say the same value? They do have the same value. So which sign would I put? Greater than, less than, or equal to? Oh, good job. I'll put equal to. They are equal to each other. Well, how do I know that they're equal to each other? So here we write how we know they're equal to each other. So I know that my objects, or my Skittles, my drawing, and my equations all show that even though the colors are different, Matt and Meg have the same amount of Skittles because the Skittles have the same value of 1 10 and 3 1s. Good job, guys. We did it. We took that problem and we did it. We did this beautiful, oops, I hit it. They went my Skittles. So we had our objects here. We showed our part to total structure drawing, and it showed us that both these numbers turned out to be the same. They have the same value, meaning they're equal to one another. You did an awesome job. I'm so proud of you. Tomorrow, Miss Ramsey will be with you for math, and I will see you back next week on Monday with some more math. I hope you have a wonderful day. Love you. Bye.